Okay, let's look at y is equal to x cubed. Now, I've been saying all the way along through the course, I am differentiating the y. And when I differentiate the y with respect to x, I get dy dx. When I differentiate x cubed with respect to x, I multiply by the power and I put the power down 1. Now let's look at a slight variation on it. Y squared is equal to x cubed. Now what we have here is something which we've seen before called the chain rule. And the priority A function, if you remember, is the power. And the priority B function is the y value. So when I differentiate this, I multiply by the power and put the power down 1, and then I multiply by the differential of what's inside, which is the y, and the differential of y is dy dx. And over here, multiply by the power and put the power down 1. So the answer is 2y dy dx is equal to 3x squared. Okay, we'll look at next one, number 3. So y is equal to, so y cubed is equal to x to the power of 5. Once again, we're going to look at this chain rule, and the cubed is the priority function, and the y is the secondary function. So differentiating the power first, I multiply by the power, which is going to be 3, and then I'm going to put the power down 1, so 3 goes down 1 to 2, and then I multiply by the differential of what's inside, and the differential of y is dy dx. And when I differentiate x to the power 5, just with respect to x, it's 5x4. Let's go on to another one. If I've got sine of y is equal to 3x squared minus 6x, I am differentiating this equation with respect to x. So what's the priority function this time? The priority function is the sine. What's the secondary function? It is the y. When I differentiate sine, I get cos, and it's cos y. And then I multiply by the differential of what's inside, and the differential of y is dy dx. It's equal to, multiply by the power, put the power down 1, and a constant becomes 0. So what happens? What's going on? Well, if we have a function of y on one side and a function of x on the other, and we choose to differentiate with respect to x, with respect to x. When we differentiate this function, we get f dashed. And then because it's involving a y, we have to remember to multiply by dy dx. When you differentiate an x function, it's just g dashed x. So when you're differentiating a y function with respect to x, when you finish multiplying by the power and putting the power down one, or whatever other rule you have to apply, you must remember to multiply by dy dx. Okay then, let's look at a proper example. It says here, use differentiation to find the slope of the tangent to the circle x squared plus y squared equals 25 at the point 3, 4. So we're looking for the slope of the tangent. The slope of the tangent means that's the same as saying find dy dx. So at this moment in time, we've got x squared plus y squared is equal to 25. We're going to differentiate with respect to x. When we differentiate with respect to x and it's an x function, we just multiply by the power and put the power down one. When we differentiate a y function with respect to x, we do the same thing, multiply by the power, put the power down one. But because it's a y, we have to remember to multiply it by dy dx, and that is equal to 0. Now the next thing is, it says find the slope of the tangent to the curve. That means find dy dx at the point 3, 4. So what they've told us to do is to find dy dx when x equals 3 and when y is equal to 4. That's what that says. That could be in your head, don't have to write it down, but you can write it down if you want. So over here, what do I now know? I know that x is equal to 3 when y is equal to 4. So now I'm going to substitute in, so the x is equal to 3 when the y is equal to 4 on dy dx is equal to a grand value of 0. Tidying up 4 in. And so therefore on the tidy up line, we've now got 6 plus 8 on dy dx is equal to 0. So we now have 8 dy dx. We bring the 6 over. When we bring the 6 over, we change the sign, so it becomes minus 6. And now what we need to do is divide both sides by 8. So we're going to be dividing both sides by 8, and therefore dy dx is going to be equal to minus 6 over 8. So dy dx is going to be equal to minus 6 over 8. Of course, you should know that minus 6 over 8 cancels down, 2 goes into both the 6 and the 8, and we end up with minus 3 over 4. And we've completed the question because the question asked us to find the slope of the tangent. And let's just do a quick revision of early lessons. Slope of tangent expression also means slope of curve. It also means slope of tangent to curve. Any of these phrases mean the same thing. And of course, it also means dy dx. So that is the end of that problem. This is different from what's in the textbook on page 349. They didn't specifically ask for the algebraic version of dy dx. All they asked for was its value. So we can cut corners and save time. Always read the question. Okay, last example today. We're going to use differentiation to find the tangent to the circle x squared plus y squared 6x minus 2y minus 15 is equal to 0 at the point minus 6 minus 3. And then it says, hence find the equation of t. I'll come on to that in a few minutes. So up here, we write down the equation x squared plus y squared plus 6x minus 2y minus 15 is equal to 0. We already know that we're trying to find the slope of the tangent, and we know that slope of tangent means dy dx. So we have to differentiate each term with respect to x. So when we differentiate x squared, we multiply by the power, and we put the power down 1, so it becomes 2x to the power 1. Now we're going to differentiate y squared, which is going to become multiply by the power, put the power down 1, but you've also got to remember to multiply by the differential of what's inside. When it's a y function, you have to multiply by dy dx. Differential of plus 6x is quite simply plus 6, and the differential of minus 2y is minus 2, but it's a y function, so we've got to multiply by dy dx. Differential of a constant minus 15 is equal to 0. Now once again, you must read the question in order to save yourself an awful lot of work. And the question specifically asks you to find the slope at the point minus 6, minus 3. So you do not have to rearrange this equation. You just have to work out the value for dy dx. So we know the point is minus 6, minus 3, so the point is also xy. So now we use the empty bracket method. So 2 empty bracket, replace the x by minus 6, plus 2 empty bracket, replace the y by minus 3, and then we have dy dx, and then we have plus 6, and then we've got minus 2 lots of dy dx, and that's equal to 0. Tidy up line. So we've got 2 lots of minus 6 is going to be equal to minus 12. 2 lots of minus 3 is going to be minus 6 dy dx. Plus 6 minus 2 dy dx is equal to 0. We're going to leave the dy dx's on the left hand side and move all the numbers to the other. Seem to have missed out a plus 6 somewhere along the way. So just slip that in there. I'm sure none of you noticed the deliberate error. Now we move on. Minus 6 dy dx minus 2 dy dx is equal to, moving the minus 12 over, plus 12, moving the 6 over, becomes minus 6. Minus 6 minus 2 gives us minus 8 lots of dy dx is equal to 6. Change one sign, change them all. So 8 dy dx is equal to minus 6. And now we're going to divide both sides by 8. So dy dx is equal to minus 6 over 8. So dy dx is equal to minus 3/4. So dy dx is equal to minus 3/4. Okay, so that seems to be the end of part 1. Now part 2. We'll move to the next page, and let's just paste the question back in. What do we have from the previous page? We have dy dx is equal to minus 3/4. Okay. Now, let's have a look at the question again. Don't forget, don't make too many big steps. Just have a look at what needs to be done, do it, and then take stock. Now, what it says here, it says, hence find the equation of t. Well, what is t? Well, t is a tangent. T has got a special name. It's called a tangent. And a tangent is a straight line to a curve. So when it says find the equation of t, it's saying find the equation of a straight line. Now we know what the straight line formula is. It's y minus y1 is equal to m on x minus x1. Gather your information. What point do we have? The point is still minus 6 minus 3. But this time we're calling it x1, y1. The slope, dy dx, m, is equal to minus 3/4. So all we've got to do now is substitute it in. So y minus minus 3 is equal to minus 3/4 on x minus minus 6. Tidy up line, y plus 3 is equal to minus 3 over 4 on x plus 6. We're going to multiply both sides by 4. So if we multiply the left-hand side by 4, we end up with 4 brackets y plus 3. And if we multiply the right-hand side by 4, it cancels the 4 out from the bottom. So now, once again, another tidy up line. We've got 4y plus 12 is equal to minus 3x minus 18. And we're going to bring everything to the left-hand side. So the minus 3x comes over and it becomes 3x. So that point is done. The 4y is already on the left-hand side, so it remains as 4y. The plus 12 is already there. And the minus 18 is coming across to join it, so it's going to be plus 18. There's nothing left on the right-hand side, so it's equal to 0. Tidy up, we've now got 3x plus 4y plus 30 is equal to 0. Oh look, as if by magic, a graph has appeared. Wow, what happened? The maths fairy. So what we have now is just to explain to you the geometry of the situation. You'll find out that next year that this thing up here is the equation of a circle. That didn't go too well. Let's try that again. This thing here is the equation of a circle, which is pictured in red on the diagram on the right-hand side. And what we were looking at was the equation of a tangent. A tangent, this is the line which is called a tangent, the blue line. It's a line that actually touches a circle at the given point. And of course, the given point was at the point minus 6, minus 3. You weren't asked for a geographical representation of the situation, but I just wanted to show you anyway. Okay then, good luck with the exercise. What I would do, just to keep my life simple, is I'm going to write down what questions I want you to do on the next page. So make sure you look at this video to the end. So what we have, we've got exercise 13.9. That's on page 350. And the questions I want you to actually work on is question number 1, part 1, part 3, and part 5. Question number 2, part 1, part 3, part 5. Do you want to have a guess about number 3? I think you've guessed it, haven't you? Part 1, part 3, part 6. Nah, only joking. Part 5. Question number 4. Definitely do question number 4. Why wouldn't you? It's a lovely question. And is there anything else I want you to do? I think I ought to give you number 6. I think you might struggle with this one. If you do struggle with it, I would just going to give a few seconds. I'd like you to stop the video now. Count to 5. 1, 2, 3, 4, 5. Because I'm going to do number 6 on the next page. And I don't want you seeing the answer. So I'm just going to pause for a few seconds, and now I'm going to do not number 5, number 6. Okay then, so here's number 6. So it's x minus 1 to the power of 2 plus y plus 2 squared is equal to 5. And they want you to find the equation of the tangent to the curve at the point 3 minus 3. So we're looking for the equation of the tangent, so we're going to be looking for a straight line. And a straight line is y minus y1 is equal to m on x minus x1. Now, we already know that x1, y1 is 3 minus 3, so we can move that equation on. So y minus minus 3 is equal to m on x minus 3. So y plus 3 is equal to m open bracket x minus 3. So in order to solve this problem, we need m. Of course, what does m stand for? M stands for slope. What is the slope function? The slope function is dy dx. So we're back over to the left-hand side, and we're going to be differentiating this. The first bracket, which I'm going to highlight in the pretty colour green, is basically a function of x. So when we differentiate it using the chain rule, it is as per normal. Multiply by the power, put the power down 1, nothing inside changes, and then we multiply by the differential of what's inside, which is 1. Now we're going to go on to the next one, which is y plus 2 squared, and we're going to multiply by the power, which is 2. We're going to put the power down 1, which means it goes down to 1, and then we multiply by the differential of what's inside. So what's the differential of y? Well, you should know by now it's dy dx. So it's dy dx. What's the differential of 2? Well, that's 0. Moving to the right-hand side, what's the differential of 5? It's 0. Just a little tidy up line. So 2 bracket x minus 1 plus 2 bracket y plus 2 on dy dx is equal to 0. Now we are looking for the value of dy dx, and what we know is we're looking for it at the point where x equals 3 and y is equal to minus 3. So let's substitute it in. 2 open bracket 3 minus 1 plus 2 on minus 3 plus 2 on dy dx is equal to 0. Tidy up, 3 take 1 is 2, 2 2s are 4. So that's now going to be equal to 4. Minus 3 plus 2 is minus 1. Minus 1 times 2 is minus 2 on dy dx is equal to 0. Bring the 4 over, so minus 2 dy dx is equal to 4. If we change the sign on the left-hand side, we have to change the sign on the right-hand side. So 2 dy dx is equal to 4. And now we're going to divide both sides by 2. And when we divide both sides by 2, we end up with dy dx is equal to 2. And let's not forget that dy dx is the slope function. So we've now got the value for m, which is equal to 2, which we can now put into this equation up here, which is going to be y plus 3 is equal to 2 on bracket x minus 3. So therefore y plus 3 is equal to 2x minus 6. I'm going to leave the y on the left hand side and bring everything to the right hand side this time. So y is equal to 2x minus 9. And that's the end of the problem. And if you've got it wrong, you're now looking at this, and if you've got it right, well, give yourselves a clap on the back and a jelly bean. All right, well done. Bye.